All right, so I just want to do more of this threat hunting with Splunk. So you got the great thing about it, from your point of view, you don't have to install anything. You just use my cloud server where the Splunk is already installed with the data you need. So here you see it has about 1 million events from years ago. And so I'll pick up with this brute force attack, which I think we covered last time, but it's a good place to get started. So to get the brute force attack, I want to find the events using the post method. So I want to go to data summary and then source types and then find HTTP traffic and stream ICMP. I guess I got to make this a little bit smaller. There. Stream HTTP should be one of these options. There it is. All right, so there's the HTTP traffic. Now I get nothing because I'm not looking over the right time period. I'm looking in the last 24 hours. So I'm going to turn on some event sampling just to make it faster, like 1 for 10, and then go to all time. And I should have 15,000 events, which will mean 1,500 out of 1 to 10 sampling. All right, 2314, that's a little more than I expected. But they're all here in 2016, which is when the attack happened. On a 1 or 2 day period in 2016 is the right data. So I think it's all right. Let's exclude the events from the... First, let's make sure this number is right. 15,570. Let me get rid of my sampling, because this is pretty far off. So I wonder if something's wrong. And I was a database analyst for years, and one thing I always relied on is the number of things found. That was the normal control to make sure you're doing the right thing. And see, I do have too many events. Wow. That's interesting. Oh, that's why. Because I want the ones using post. This is all of them. It's also including the gets. So I also need to filter for post. So that's down here, HTTP method. There. I want the post events and nothing else. And now I'm going to get 15,000 and change. Yep, 15,570. I'm on the right track. Okay, now I want to get rid of the ones that came from the vulnerability scanner. And we talked about that before. I think I can make this a little better. That's not, and it has to be capital, Acunetics. This, I think, that's the word that will appear in all the vulnerability scanner data. It's the name of the scanner. Yeah, now we're down to 441 events. And now we want to look at the form data of these. So we make a table like this. And that will give us a list of the data. And some of these are not part of the attack. But if you filter for time to the other end of time, these are the attack. Username is admin, username is admin, username is admin, and the password is just a bunch of different things. So this is the attack. So to get rid of ones that are really part of the attack, I want to have this phrase in there, username equals admin. So I'll put that in here. There. It should have that, or it's not part of the attack. And so now I get the 413 events, and they're all going to be part of the brute force attack. And if you sort by time, here's the start of the attack, 21.22, 21.24, 21.24. This is many guesses per second going by. And at the other end, you find the attack went on. Here it is coming up, 50.6, 50.8, 51.1, and then 2 minutes. So this is the automated attack, which went this far and finished, because it found the real password. Then the attacker logged in manually over a browser a couple minutes later on a different machine. And you can tell that it's different because this has username here and the password right there. It's a different format than this, which has username and password over there. So this is the script. This is a Python script trying many guesses per second, and then it found the right one and alerted them, and this is the person logging in a browser. And you can also tell that if I get rid of the table, then you can look here at, say, the user agent, and you can see 412 of them are Python, and 1 is from a real browser, like Mozilla. So this is the, and you can also tell by the source IP address. Source IP is here. 412 came from that address. This is where he ran the script, and this is where he logged in manually. So you can see what happened here. And so these are two IP addresses of the attacker, and that's useful information to know. I'm going to make a note of that.
Do you ever look up the IP address?
Yeah, so this is the IP address the script ran from, and this is where the attacker manually logged in from. So these are both attacker IPs, and those may be useful. And traffic to these is clearly an indicator of compromise, so that's the kind of thing you find by analyzing one attack, you learn useful information, which will help you find more. Because if they did something else, they might have reused these servers for the other part, like download more malware from them. So knowing that these are part of the attack is useful indicator of compromise. And so they uploaded an executable file. What they did, this was an attack against the control panel of the content management system. They tried 412 passwords until they got in with the right password. Then they were able to upload a file and run it through the management console. This is how they gained execution on the web server. And they uploaded a file. So let's just look for exe files here. This part is all fine. And now instead of looking brute force attacks, we're going to look for .exe files. And you'll find there's two such events. And if I just use the browser to search for .exe, then you can see right here, he uploaded a file called 3791.exe. And whoops, something bad happened. Let me go back here. There. I just wanted to highlight this and put it in my list of notes. That's the executable that he uploaded to run. And, all right?
So even if that executable has been wiped from the computer, you still have a record that it entered?
Yes, because I'm looking at log files. Yeah, it could be gone, but I have a record that it went by. That's why you want to have good logging. Yeah. And the logs are exported to a central server for Splunk. So even if that whole machine is wiped, I still have a log of what happened. That's right. That's why this is so popular. Yeah, you want to send all your things. That's why everybody uses Splunk. It really is the records you need in a way that's easy to use them. It's easy to find the answer. I've got 1 million events, and it's this easy to zero in on the one or two that matter. That's why that's why this is a great product. So we found the name of an executable. We can find its hash. And here's more about the brute force. These we already know from that brute force attack. How many passwords were used? What was the correct password? What was the time interval between when the Python script found the password and the bad guy? And how many passwords did they try? Those are all easy. This one is a little harder to get the MD5. And this is why I mentioned you should run sysmon on your Windows server. It's an extra sysinternals tool, not included in a default install of Windows, but sysmon gives you very good events. And we want a process creation, which is sysmon process type 1. So let me just go to home of the search and go back to data summary. We're going to look at sysmon events. And that's here, sysmon operational. This is the long name of sysmon. And there's 270,000 such events. I click on this. And so now I'm going to turn on sampling because that's a big number. I'll do 1 in 100 and all time. And we'll get representative examples of sysmon events. And we'll find that there's an ID down here, event ID. And event ID 1 is process creation, which, by the way, you can find here. Here's the page about sysmon telling you how it works. And you can see here's sysmon, and here's the types of events. There, 1 is process creation, 2 is changing your creation time, 3 is a network connection, and so on. So when they installed that executable, they ran it, and that created a process. So that should create a sysmon event type 1. All right, and let's see, this might be land-eating something, or it might be a crook trying to steal my money. Oh, it's just a sec. Hi, I'm Sam. Can I help you?
Hello, Sam.
Yeah. Yeah. Good. Oh, good. How late are you open today?
Well,
Well, I'm teaching until 2, so maybe I can't get it. Yeah.
oh, no, okay, no problem. I'll be happy. I'm just doing a lot of
Yeah.
I'll be happy to hear.
Okay, I'll probably be maybe 2:30 or 3 when I can get there.
Sounds good.
Okay, I'll be there. Thank you. Okay, bye. That's good. All right. My car's been in the shop, so I'm glad to get it back. Anyway, so, all right. So we're going to look for event Sysmon type 1, which is here. All right. And I guess I can turn off the sampling. I only found 4 of them, so there's only going to be something like 400 of them. And now I can know the file name I want, which I think is what I want to add. They say command line. All right, you're trying, I guess we can try command line. Let's see. Command line is here. There's more than 100 of them. I think I can just put in the name of the thing, 3791.exe. That should narrow it down. Yep, now I have 5 events. All right. And now I could make a table with, say, time and command line. I don't care about anything else right now. All right, so there we are. CMD, here's running 3791, and here's running the CMD container that's going to run 3791. So one of them is going to be it. And so if I get rid of the filter here, you'll see what a Sysmon log entry looks like, and it's really very handy. If I do this, it'll break up the fields, and you'll see it gives me the hashes of the file. It gives me SHA-1 and MD5 hashes of the file. Here, MD5 hashes of everything that executes, which is very handy. So, in fact, if you go back to here and just look at the MD5, there are only 3 MD5 values among these 5 events. And one of them is the 3791, one of them is CMD itself, and one of them is, I think, something else like con host. So one of these is the right answer. And it's a little confusing to figure out which one is exactly 3791. But anyway, that's why Sysmon is great. Easy to understand, and it gives you the information you really need, like the hash, so you know exactly what ran. Sysmon is a great tool. All right. And so let's do a bit of this ransomware attack. To find the IP address of this machine, we're going to have to find the network traffic where it logged in is what we're going to do. So we'll start searching for this and find 181,000 events. So I'm just going to go to a clean search page. Yeah, you need something?
We have an extension? We need extension.
I don't have one.
Oh,
Extension
no.
cord? I know, I wish I could use one too.
Oh, yeah.
Yeah, but if you open the panel in the back of the table, some of them can reach the power.
Okay.
Yeah. Okay, good. All right. Anyway, good. Let's go to a clean search page. And, all right, I want to look at this W8105 desk. That's the name of the machine. So again, I'm going to turn on some sampling because there's a lot of them.
It's the name of the target machine.
Yeah, that's the machine. But they have some reason to believe this machine is involved in the attack. So something probably the ransomware popped up on their screen or something. So we want to find the IP address of that machine. All right, here's some events. And now what we can do is examine the source field and look at streams that are used for Active Directory logins. And it turns out stream data, if I go to source type, stream Active Directory logins happen over LDAP. Now you don't see it here, so let's lower the filtering. I hit I want to go back to all time. I accidentally hit the bar and that limited the time. All right, I want to change my sampling to 1 in 10 to see if I can find more rare events. All right. So now I got 18,000 events. And now if I look at the source type, now I have stream LDAP. These are Active Directory login events, Lightweight Directory Access Protocol. And when it logged into the domain controller, it must have sent a signal from this endpoint to the domain controller. So I want to look at these events, and now I can see that the destination IP is always this. This is 192.168.250.20, and the source IP is this, 192.168.250.100. And here you can go by convention. The convention is servers have low numbers at the end, like 10 or 20. clients have high numbers at the end, usually starting at 100. So this is the workstation, and that address ending in 20, that's the domain controller. So this is the endpoint address, which was the question here, to start us on this investigation. So now we want to find the server signatures, and we'll find the domain name that it went to at the end of its encryption page. Let me go up here. So to find server, I think we're just going to look at server and the source field. All right. So let's clear all this and just look for what, I don't need that right now. We went server. Okay. We're going to see what mentioned the name of the ransomware, server. And, all right, quite a few events. I still have 1 in 10 sampling going on. And now we're going to look at the source field and go to Suricata. So let's go to source type, and Suricata is here. We want Suricata is an intrusion detection system, so we want its events that alerted on that detected server. And so there's 0 because there aren't very many, and I'm sampling. Let's quit sampling, and now you find the 5 events. So Suricata had 5 alerts, and you can get the information down here. A severity ID. Suricata signature ID, there are, and those are IDs, and there's even a better description of it, alert type or something like that, alert action, alert signature, there we are. So here, this was kind of useful. So what happened is, here's Suricata. In fact, it would be nice, it's alert signature. Let's make a time chart of this. That's a handy way to look at it. Pipe, time, and alert signature there. Oh, yes. Well, perhaps I did something wrong. Let's try getting rid of that. Let's go back to here. Okay, it was alert dot signature. That's why. Okay. If you're going to refer to names here, they have to be exactly right. Dot. Okay. Still doesn't like it. Well, how rude. All right, let me go back to the original one and figure out what I'm doing wrong here. Let's do it another way. Alert signature is here. So let's have events with this field. That'll put it up here. Okay. Now, I should be able to pipe that into a table. I think I forgot the word table is what happened. Yep, that's what I did. I forgot the word table. Yeah, and now I want the time also. Underscore time, well, not there, but here. Okay. Underscore time, comma, there. There we are. And now I can sort by time. So here's the actual progress of the attack. It observed check-in. That's when somebody first ran the malware. Then that was at 9:49, and then it observed an ICMP response. Then it checked in again. There's 2 responses. This all happened within a few seconds, a fraction of a second here at 9:49. Then it started encrypting files, and it continued for half an hour. And here's where it popped up the ransomware demand. So this is the complete timeline of the ransomware attack. It started here and it finished there. And the question, so there's various things to find here. And one thing you want to find is the domain name where the ransomware attack came from. So this is where the onion domain lookup happened at this exact time. So if I click that time, I can view events, narrow to this time range, and I can make it, and let me go back. I want this time. Let's just sort by time again. There, the onion domain lookup. I want this time. There's a way to narrow it to like within 1 second of this time. And I think it might be this. Not yet. There's a way to do it more easily. I've done it before, and I'm having trouble finding it. There's a way to get to exactly that time, plus or minus 1 second. And here, restrict it to time within 1 event. Yeah, restrict the search to alerted signatures. There's a way to get within 1 second of an event. and I'm not succeeding at doing it right now. Let's see if I can figure it out. These are the two events I want.
Would it be under format timeline? Maybe
Yeah,
the back page.
yeah, there might be. I think there's a way to do it here by clicking on a time. There is some way to narrow to within a region. This is 668 to 669. Right now it's within 1 millisecond. And I think there is, if I just click on that, yeah, I'm not having much luck. All right, there's the time. I think I can go here and fix it. There's an easier way, but I can't remember how to do it now. There's some way to do plus or minus 1 second. But anyway, I can look here, 10, 15, 12, 668 to 669, and I can make it like 11 to 13, give it like a 2-second range. Because I want to find the DNS lookup that's associated with this. So that's one way to do it. It's important to do it with the mouse this way because time zones are a problem. When I taught this class in the middle of America, everybody was off by like an hour. So that's why you want to start by clicking on the event and then modify what it gives you. Then you'll be at the right time. So, and I think it's going to make me put an extra place here. Oh, that's right, milliseconds. 0.000 there. It's not in the right format, so I do that there. Now, hour, minute, seconds, point. Minute, seconds, point. Okay, it doesn't. Oh, there it is going to let me apply. Okay, good. There we are. Now I've got the events in this range. And now what I want to do is search all events and look at DNS related fields. So I want to remove all this information and this and just look at all the events in that time range. And I'm still finding only 2, so I think I want DNS. I don't want Suricata. So I'm going to look at all the events for those 2 seconds, and there's going to be a lot of them. 1,300. And now if I go to source type, here's DNS. And there were only 2 DNS resolutions in that time range. And if I go down here, query, there, that's the malicious domain. Server something, this is the malicious domain that loaded the ransomware. And this is actually a link that goes behind Tor apparently, but that's the malicious domain. That's what they asked you for. Find the domain that it loaded the ransomware from. So it's pretty tricky because DNS requests don't have any additional information in them. Anyway, that's how you find the fully qualified domain name of the ransomware server that is serving up the. And so then you can find the first suspicious domain visited by this object on 24 August. So we look at Suricata coming from that machine, and then look at event type. That's why this IP address we noted earlier is going to be useful. So we want Suricata events, source types, Suricata, which is here. Okay, and I'll go to like 1 in 100 and all time. Okay, now I want this address ending in 100, 250, 100. That's the machine I want a Suricata alert from. So I look at the source IP, I think. Yep, source IP. All right, and there it is. A bunch of events come from that machine. All right. And examine the event type. Okay. And I want HTTP, things that loaded web pages, because this computer went to a suspicious page, and that was part of the attack. And so I go to the HTTP, and now I'll get rid of the sampling to see all the events. And there's 616 such events. And now we look at the host names. And those are down here. And HTTP host name. There are 31 of them. So you see these are usually pretty harmless ones like Windows Update and so on. So I'm going to, I'd like to just see the unique values of these. HTTP host name. All right, there's various ways to do it. there's a way, I think, to get unique values, which is probably going to help here. Let me see if I left myself any good notes. There are 10 host names. There should only be any. Oh, there are 30. Oh, I'm having far too many events. Oh, Suricata events. All right, Suricata, source IP. Suricata, source IP. Event type is HTTP. There should only be 38 events. But I have 616 events, so that's where I'm getting a little confused. I have somehow included stuff I didn't mean to include, and I don't see what I've done wrong here. Examine the host names visited. There are 10 of them. Well, let's try, I think it's unique. Splunk, how to see unique values. I think it's just pipe unique. There, dedupe, that's right. So it's going to be index pipe dedupe user. Okay, good. Let's try that. Pipe dedupe, and it's HTTP host name. And then let me make sure I'm going to spell it right. HTTP.hostname. Let's see if this works. Somehow I've got something wrong where I'm seeing 600 events instead of 38. But now I'm down to 31. So I don't know why I got duplicates. And now I've deduped it. And now I want to see them all. So let's just do a table of hostname. HTTP hostname. All right. And so here they are. And if I look at this one, looks funny. Solidarity, proximity. The rest are pretty obviously harmless, like Bing or Microsoft or Cronus, Live, and some other things here. But this is the one that looks funny, and that's in fact a malicious one. Solidarityproximity.org. All right. Anyway, that's how you find a suspicious domain. And I think the last one I'll demonstrate here is the VB script. That's good, clean fun, and that's enough for one day. But we're going to find the VB scripts that run. So we're just going to look for VBS and EXE. It ran an executable that then ran a Visual Basic script, which is a fairly common way people get hacked. So we do .vbs and .exe. And there are only 16 events out of the million where that happened. And we look at the body field, and there's only 6 bodies, and you can tell right away one of these is incredibly obviously malicious. This looks normal. This looks normal. This looks normal. And this is the malware. You can see this garbage. GP. This is deliberately written to be confusing with the crazy capital letters and garbage. This is malware. This is what script-based malware looks like PHP script and VB script. They write it in a confusing way for just this reason. And so this is in the body field. So if I do this and I do pipe, I just do a table of body to get rid of everything else. You know, see the body here. And those are normal. There it is. This is the command that did the malware infection. cmd.exe set, and this is the script. It makes a random name ending in VBS, and then it runs this script. And here's a loop that's going to do things. That's the whole script. You can see all the code, and you can figure out what the script did. And there's a variety of questions. They ask you what's the name of the first function in the script and things like that. How long is the script, and so on. So, like I say, that shows you an idea of what you can do here. I don't think I'll bother with the rest of this. You can do them in the projects, but you can find out how many files it encrypted and so on as you watch it go. So that's the point of Splunk. And I think really that's enough demos of that. Let me stop this recording.